Welcome back to our third lesson. Today we're going to cover for loops, and we're going to cover 3 problems ranging from easiest to most challenging, but of course this is just subjective, and so if you want to skip around you can. So the first problem we'll do is taken from a 2016 CCC competition called Tournament Selection. So basically each player plays 6 games and there aren't any ties, and so the tournament director needs to place the players into groups based on the number of wins. So if a player wins 5 or 6 games, they're placed in group 1. If a player plays 3 or 4 games, they're placed in group 2. If a player wins 1 or 2 games, they're placed in group 3. And if a player does not win any games, then they're eliminated from the tournament. For our second problem, we're going to quote-unquote find red hex codes. So given RGB value of a color, we need to find if it's considered a particular shade of red or within a range. And so we have the range here. And given n colors, where each color is an input as in RGB as a line, we want to output the amount of red colors. And for our third problem, we're going to cover printing patterns of triangles, which requires nested for loops, so it's a bit more complicated, and we'll go over that as well. So this is basically the quote-unquote formula for a for loop. So first we need to initialize it. So initializing means just creating a variable for the amount of times or the count of how much the for loop needs to run through. So for the initialization, we put it first, and then we end it with a semicolon. For our second condition, we have a termination condition, and this basically defines the condition. So normally it's like the initialization variable is less than an integer. So let's say we want to run it 5 times, and the initialization variable is called I, and we equate that to 0. So I is normally what people use, and if it's a for loop within a for loop, people might also use J or K, and that's basically how most coders use for loops. You don't have to use letters, it's just the easiest, and also like universal in a sense. And so if you want to run it 5 times, you can do I is less than 5 and not equal to 5 because we start with 0. And then we have the update statement. So this gets executed every time until the code within the for loop is filled. In order to increase the initialization variable from 1 to 5, we can just add 1 to the value. So we can just do plus plus instead of plus 1, like so. They mean the same thing. And a for loop is when we know the amount of times that we want the code within these curly brackets to iterate or repeat. If we don't know the amount of times, we need to use a while loop, which we'll go over in a future video. So this is basically what a for loop is. So we have initialization variable. We initialize the variable I to be equal to 0. You don't have to make it equal to 0, it's just easiest, most simplistic. And then we have the condition. So basically it checks the integer I. If I is less than 5, then it'll run this code. And since I is equal to 0, it'll print out 0, like so. And now it adds 1 to I. So now, instead of 0, I is equal to 1. It checks if I is less than 5, which it is, so it'll print it out, and now it'll add 1 to the value. So now I is equal to 2. So that repeats until it's reached a value that's not less than 5. So let's say it just printed out 4, and now it adds 1, so it'll be 5. It checks if 5 is less than 5, which it isn't, so then it doesn't run whatever is in the brackets, and it moves on to whatever code is below it. And it's also possible to repeat loop variables. So for example, if you want to have another for loop that's not related to this and it's outside the original curly brackets, we just do the same thing. You can use the same loop variable name. If it's in a nested for loop, which is a for loop within a for loop, and you can basically have infinitely many nested for loops, you have to use another variable. So it would be j or k, m, etc. This is an example of a nested for loop. It's just a for loop within a for loop within a for loop, and so on. So I just want to reference last video where we went over if statements, and there is a simpler way of combining if statements if they're about the same issue. So for example, we can combine them by using else if statements in between, and we can just sandwich them. So else if statements can't exist on their own, they have to be under an if statement, like so, and same for else statements. So this will make it more concise if there are maybe like 13 other cases. You don't really want to be writing 13 individual if statements. It's just a bit too much. So instead, if we use an example, then if a number is greater than 5, so let's take the number 5 for example. Last time we just grouped it into yes, it's greater than 5, or no, it's less than or equal to 5, but now we can make it more specific. So if the number is greater than 5, it would go under yes, if it's not, it will go under no, like so. But since 5 is not greater than 5, it'll go here, and now it has to decide if it's less than or equal to 5. Since 5 is equal to 5, this is the outcome. We need to print that the number is equal to 5. Now let's say if a number is 3. So since 3 is not greater than 5, it needs to decide if it's less than 5 or equal to 5, it being the computer. And since it's less than 5, we need to print that the number is less than 5. So this is one way you could do it. Not the best, but it works. So as you can see, the number is equal to 5 if the number is less than 5 or the number is greater than 5. Of course, there's a better way of doing that with else if statements. So if the number is equal to 5, then the computer will print out that's equal to 5 and it'll skip to the code underneath. If it's not equal to 5, it'll go to this condition. And if the number is less than 5, like 3 in our previous example, then it'll print out that it's less than 3 and skip the else statement and go to the code underneath. If the number does not fulfill the first or second condition, it'll go to the else, basically just print out the number is greater than 5 because that's the last case left, and it'll go to the code underneath. So that's basically a simple or concise way, at least, of else if statements. So the first problem, we want the user to input how many times the player has won a game. So in order to get user input, we need a scanner. So as you can see up here, I've imported the Java package for the scanner. You can just get the scanner by doing scanner, and then the scanner name, and then new scanner system.in semicolon. Sometimes what I like to do with problems like this, I like to try to think out what variables do I need. So since we need to figure out how many times the player has won an X amount of games, we should have a count variable of some sort. Since we don't know the value, we can just set it to 0, and we can just initialize it up here. So another variable that we need is the user input for the amount of times the player has won the game. Now in this case, they'll denote it if the player has won by using a W or an L, like the letters. So W for a win, L for a loss. So we can initialize the variable of the user input by just giving it empty quotation marks, like so. Now we need the for loops. So what we could do, since it is 6 games, we could just do a letter equals the scanner dot next line. You can do dot next, but I just prefer next line to reinforce that it's a string. So you could do this, and you can also basically do an if statement. So if the letter equals, so in this case I'll do dot equals and then brackets the letter I want. Then we'll add 1 to count. So we can do count plus equals 1 like so, or we can do count plus plus. They both mean the same thing. So why did I do dot equals instead of something like this, letter, the 2 equal signs W? So basically this means that you're trying to find if what the letter is equal to the reference point and not the value. So the reason why we can use this for numbers, like integers or doubles, it's because we're referencing the, like, where the number is placed, if that makes sense. We're not actually seeing if a number is equal to a number, we're just seeing if they are both found in the same reference point. But since we need to see if it's the same value, we need to use dot equals, which is a string method, and we'll cover that probably sometime in a future video. So we could just repeat this 6 times and get the same result. But since we know that for loops exist, we can make our code more concise and simpler. So for this, we just do for brackets, we need our initialization variable. So int I equals 0. And since we want it to run 6 times, we do I is less than 6 and I plus plus, because we want it to increase by increments of 1 with our condition. Again, we don't want it to be greater than or equal to 6, because technically that would run 7 times, since we started with 0. If we started with 1, then we could make it equal to 6, but in this case we started with 0. And of course we need our brackets, so that's just how we saved lines and time by using this for loop. Now we need to give the user what group they're in. For this we can use if statements, or else if statements, or else statements. So if count is equal to 5, or if count is equal to 6, you can also do this in other ways by saying if count is greater than 4, or is greater than or equal to 5, that also works. So you can try that out. So we can do system.out.println 1. So that means they're in group 1. We can repeat this by saying else if count is equal to 3, or if count is equal to 4, system.out.println 2. We can do else if count equals 1, 2. We can put them in group 1. And we can just do else for everything else. System.out.println. We can say -1 to denote that they're eliminated. And that's basically how we were able to make our code more concise by using a for loop and by using last week with else if statements. Okay, so let's run the code with some values. So let's try to get the player wins 3 games, but they're placed in group 2. So let's see. 1, 2, 3. Now they're placed in group 2. Let's just test with that they won every game. So just input that. They're in group 1. And if they lost every game, they're eliminated. Well, let's test the last case where they win 1 game. So they're in group 3. So that's basically how you solve this problem in a few steps. Again, what I meant previously, you can just do count is greater than 4 instead of using or operators, but since we learned that last time, I thought it would be better to use that.
Alright, so let's look at what we have here. So we will be given n amount of colors, and the first integer will be n. Let's dissect the problem step by step. So we know that for our first step, we want to do java.util.scanner. This way we have a way to take in the input. We need to take in the input because we'll be given a number n, and then we will be given n amounts of colors. That's why I'm going to start by making a scanner, because I know that's going to be useful. And then I know that the first input that I'm going to get is the number n, so I'll make int n is equal to the first integer. So you don't need to know how to write this. Again, you really could only just copy this from your previous code if you have that, or just copy this over here, because this is just about how to get in the system input, not related to what we currently have. It is very useful, though you don't exactly need to understand what each symbol means yet. So next up we have n. We know that the next n lines will each give us a color. Thinking about how we do this, we know that we will want to do something with this color once that we have received it. And since we want to do the same thing with every single color that we get, we can use a loop. Moreover, since we know that we need to loop through this exactly n times, we know that we can use a loop where we know how many times we will loop through, this being the for loop. So I'm going to make a for loop, and so I'm going to initiate a variable I is equal to 0, because we start off at 0 and we want it to happen n times, so I'm going to have I smaller than n I plus. Plus, this is going to run exactly n times, because it's going to start at 0 and it's going to reach n minus 1. This is how you would usually write a loop from, that is, n amount of times you would write it, like this. If you don't believe me that this works, let's say n is equal to 5, you would go I is equal to 0, first loop, second 0, I is equal to 1, that's 2, I is equal to 2, that's 3 loops, I is equal to 3, that's 4 loops, and I is equal to 4, that's 5 loops. Then you're done, because when I is equal to 5, 5 is not smaller than 5. So you end it there, and that's exactly 5 loops when n is equal to 5. So once we figure out the amount of loops we have to do, let's see what we need to do with each color. And we need to make sure that our statement is generalized for every single color. It works for every single input. So what we are going to be given is a value with r, g, and b. So I'm going to start by defining int r, g, and b as 3 separate integers. Then I'm going to have r be the next integer that we receive, because that's what we will get as our input. And then I'm going to get g be the next one, and b be the last integer that we receive every line. Once we get one line of RGB, the next integer we get is an R value, which will be for the next color. So we have all the values, all the information we need about our current color. Next, we want to see how many red colors there are. So we know that there are certain requirements for this color to be red. First, the R value has to be between 200 and 255. Again, there's a lot of requirements, but you can do this step by step. So I'll start by saying so R has to be larger or equal to 200. Let's tackle this step by step. R is larger or equal to 200. Then I'm going to add the and symbol. Recall that the and symbol in an if statement means that this requirement and whatever requirement follows it has to both be true for the if statement to work. So, and then we also need R to be smaller or equal to 255. So that's one of our requirements. Another requirement we have is that we need green to be equal to 0. So to have green equal to 0, this is a common mistake. Remember that you can't write like this. You need 2 equals in an if statement to signify that g has to equal exactly the number 0. Otherwise, you'll be defining the variable g as g is equal to 0. And you cannot do that in the if statement itself. Lastly, we have a requirement that b has to be between 0 and 70. So we have b is larger or equal to 0. Sometimes they will tell you that all the numbers given are between 0 and 255, in which case you can ignore that. If you're not told that, then you should include it. And then b has to be smaller or equal to 70. So only something that fulfills all three of these requirements will reach here. Great. Now we know that the color is red. How do we keep this in our system so that it remembers and it can output that? I'm going to do this by having int red counter. This is a variable that will increase by 1 every time we have a red color. This will be an integer because we just need to do +1, +2, +3, +4. We're not going to be adding 0.5 or anything like that. Though if you wanted to make it double that at 0.1 every time, you could. It would be more annoying. Also note that this has to be placed before the for statement, because if this was placed in this for statement, every loop it would go through and it would read red counter is equal to 0. So every loop it's going to reset the red counter to 0. That means that our counter isn't actually going to save across colors. Every single color that we go through, it's going to go back to 0, and maybe it'll add 1, maybe it won't, but then it doesn't really matter unless it's the very last color. So remember that the stuff inside your for statement has to only apply to a color, and if you want something to stay beyond it, you need to place it before or after the for statement. In this case before. So here I'm going to add 1 to red counter, so I know that one color has reached here and is red. Now that I have that, again, I'm leaving the for loop because I only want this to happen once. I only want to give my answer, which is the amount of red colors, once, and that's when I'm done looking through every single color in the for loop. So this should work. Let us run it to figure it out. So first I'm going to try a number that is exactly what we want. So maybe I'll input 3 numbers. That's the amount of colors that go to input. So let's start with one that should work. So 220, 0, and 40. Then let's try one where the red value is off. So 100, 0, 60. And the others are in. This way I'm only testing for the red value. And then let me try one where the green value is off. So 220, 5, 60. Again, the other values are fine so that I know what I'm testing. All right, this gives me 1. Yeah, only the first one was correct. And I can run this again, try another, let's say 4. So maybe the first one is going to have the blue value off. 200, 0, 75. And then I'll have the next one have nothing right. -1, -1, -1. And maybe the next 2 will be correct just to make sure that my counter goes above the number 1. Alright, 2? Yeah, good. So it's best to test every edge case you have here. You have the 200, you have the 255, you have the 0, you have the 0, you have the 70. Test all of them, make sure that they work, make sure that your counter can go beyond like 1. And then only when you're done testing all of that, can you be reasonably sure that you've done all the edge cases and that your answer is correct. And as I am here, I'm fairly certain that this code is right because every edge case that I've tested so far has been correct. Though I could test more and that would increase my belief that this is correct. One thing I want to add is that this does not have to be written in this way. You could put everything in one if statement. Nothing dictates that you need to have this many if statements. So maybe I could have had r is larger or equal to 200 and r smaller or equal to 255 and green has to be equal to 0 and blue has to be larger or equal to 0, and blue has to be smaller or equal to 70 as one line. And then simply increase the red counter. This would save me an amount of lines of code, and if I were to run this, 0, 70, and 0, 65. 2 values, that's correct. I'll give it one impossible value. 190, 0, 70, 0. Yeah. So as you can see, this line also is perfectly valid. It's up to you, your preference, which one you want to write. As with a lot of things in coding, there can be multiple solutions. multiple ways to write the code. Some of them are maybe easier to read, some of them are maybe have shorter lines. It's up to you, as long as the code itself is readable and you can understand it, and most importantly, it does exactly what it needs to do. So that's going to be it for this problem, and thank you for watching.
It is a printing triangle question, and these types of questions typically I've read that they can come up on like basic coding interview exams and things like that, so it's good to know. It really helps strengthen your knowledge and understanding of for loops, so that is what this will be useful for. So we're gonna have, given an input n, print the pattern of this. So we're gonna print this kind of like hourglass pattern, and so n corresponds to the number of asterisks on the first row. So this will be 1, 2, 3, 4, 5, so n is equal to 5, and n is always odd, so it's going to be it's just for formatting. If you were to try the code that we're going to write with like 4, for example, it would not look that great. So that's why we just say that n is odd, because it fits this specific formation of the asterisks. So how are we going to do this? Well, you can see here I have a diagram, and what we're going to do, what the approach that I find is easiest, is to split this up into two parts. So here we have one part and we have two parts, and the basic approach to anything printing is to first have one for loop, your outer for loop, responsible for rows. So like 1, 2, 3 rows, like sideways, so sideways, so rows. And then you have an embedded for loop or a nested for loop inside of it that controls spaces. So you're going to print like this space and then these two spaces, and then after that, after you've printed your spaces, you have your code for printing spaces, then you have a for loop for the asterisks. So I hope you can kind of visualize that when we call on the first for loop, this one, you know, we're saying, okay, this is going to be one row. And then in this row, I'm going to print, like, for example, one space. So that's one space. And then after I printed that one space, then I'll go ahead and print however many stars I need. And then in this second row, you know, these are the sections that we have. Okay, maybe now I'm only going to print 2 spaces. And then I'll print however many stars I need after that. So we're going to print spaces, which is why spaces come first, and then stars to make this eventual pattern. And so how are we going to do this? Well, we can take a look at this diagram and see that I've split it up into 2 parts. I split it up into part 1, which I've outlined in yellow, and part 2, which is blue. So in the first one, we're going to just print like an inverted triangle. That's what I'm going to call it. So in this inverted triangle, we're going to find out first how many times we need to loop through it. So that just means how many rows. So I'm going to count this in rows. So this is going to be row 0, 1, and 2. Now you might be asking, why am I counting this in row starting from 0? Don't we usually start from 1? Well, in a for loop in Java, we will usually start that from 0, and you'll see what I mean from the code. We're just going to call this row 0, and that's just something that you're going to get used to as you program. First row is not going to be row 1, it's going to be referred to as row 0. And then from there, we need to figure out how many spaces that we need to print. So how many spaces do we need to print? Now there's a couple ways you can do this. You can just go in it with some logic. You can just throw random numbers in and start guessing the formula to print and say like, okay, in row 1, print 1, in row 2, print 2. You can do any of that you choose, but I hope that you're seeing that if we've classified the first row as 0, and there's 0 spaces here, you see there's no spaces here, right here. And then in row 1, then we have 1 space, and then row 2 we have 2 spaces. So that works out pretty beautifully. We can have our for loop just be a for loop for spaces, just correspond to for the spaces, just correspond to the row number, and then that'll be something that we can easily code. And then we're gonna print stars. So let's take a look at the star patterns that we have going on. So we have 1, 2, 3, 4, 5. Well, that corresponds to n. We're given n is equal to 5, and so the first row is gonna have 5, and the second one's gonna have 3, and the third row is gonna have 1. So we are reducing the number of stars by 2 each time. And so the formula for this is a part that you can definitely approach like logic-wise. So or like the logic makes a lot of sense. So this is 1, 2, 3, 4, 5, and then this is going to be row R. I'm just going to say R0. So we have 5, R, 0, we have 3 corresponds to row 1, and we have 2 corresponds to, or I mean 1 star corresponds to row 2. So we can write a formula for this that is going to say, okay, take if n is equal to 5, if n is equal to 5, take the number of stars, the number of stars is going to be 5 minus 2 times the row number. And I'll explain how this works, but let's look at the example. So let's look at when r is equal to 0. So if r is equal to 0, this is 0, 5 minus 0 is 0. Okay, then I'll have 5 stars, and that is right. That's right. In the second one, we have 2 times 1 is 1, 5 minus 2 is equal to 3. So we have 3 stars. Oh, that seems to be right. And you'll find that that is also correct for the last test case. So why does this work? Well, if we know that our maximum number of stars at any given time is 5, then we know that with every row number, with every row that we continue, we lose 2 stars. Look, from this row, we have 5 in here, and then we lose 2 stars in the next section. So that is why this works, is we just subtract 2 times the row number because we lose 2 stars each row. So that is the logic for the first triangle, and that's going to be quite easy to code. And now goes on to the second triangle, which is a little bit more confusing. So in the second triangle, what we're going to start again with first is the row number. Now the row number here is going to be, you know, it's kind of a weird thing to look at it. You might start to include this one. No, this star was included in section 1. Now we're on to section 2, which is just this kind of like headless triangle. And so what we're going to do for spaces is that this is the part where it gets a little bit weird. So I'll write down the formula that I came up with. Note that this formula is up to many interpretations. You could use completely different logic, but what I came up with from just trial and error practically was to say, okay, take n, if n is equal to 5, then take 5 divided by 2, which is, since this is integer in Java, this is going to be 2. And then you're going to say, okay, if your row number here is 0, then what you're going to say is you're going to say this number, 5 divided by 2, is equal to 2 minus r number plus 1. And so let's try that for the first test case. So if r is equal to 0, this is going to be 2 minus 1, which is equal to 1. Okay, boom, that's 1 space. And then for the second test case, it's going to be 2 minus where r is equal to 1, 1 plus 1, which is equal to 0. And we have 0 spaces here. So that's why that works. Now, I honestly found this with trial and error. I didn't really apply too much logic into this, just like thinking about stuff. I just kind of saw what worked. And yeah, that is the formula. You can have a lot of different formulas for this kind of thing. You can do something completely different. It all depends on you. And, you know, just you don't have to use my solution. You can just go forth and create your own if that's what you prefer, and just have fun thinking about this kind of stuff. And so after we've done that, to print the stars now, what you'll do is, actually this part is probably more easily explained while I code. So we're done with the logic here, and let's just jump into the code. So basically, I already wrote for the first part, so the inverted triangle, I wrote the code for this, and I just wanted to get to the second part because the second part is a little bit more complicated, but just to run you through the inverted triangle code, it follows all the same formulas that we talked about in the video, and this part, n divided by 2 plus 1, that's just how many rows the first part will have. So for example, if our n was equal to 5, then in our first triangle we wanted that one to have 3 rows, right? 0, 1, and 2. And so n divided by 2, integer division is 2, plus 1 is 3. As long as 0 is less than 3, then that's how many rows you have. So you have 0 to 1 to 2. You can't have another 3 because 3 is equal to 3, and that we chose less than. So this part will only give us 3 rows. That's why I did this. And basically everything else follows the formulas that I had talked about in the video. Yeah, so we'll just get into the more complicated part, which is the secondary triangle. So we're gonna say for int I is equal to 0, I is less than n divided by 2, I plus. I did n divided by 2 here because the second triangle has 1 less row than the first, so n plus 2 is 1 over here, so 1 less is just n plus 2. And now we're going to print spaces. So for that we have to do for int j is equal to n divided by 2, j is greater than I plus 1 and then j minus minus. And you'll notice that this one is different. This is why I recorded this part, is this formula is different than what I talked about in the video. You can definitely implement the one in the video if you prefer it more. I just chose this one now just to, you know, make a little bit of a different thought to have. So if n divided by 2, if our n is equal to 5, 5 divided by 2 gives us 2, right? It'll give us 2. And then so if we're on the first row, I will be 0. 0 plus 1 is 1. So as long as 2 is greater than 1 in our first row, then we will print spaces. So 2 is greater than 1 for one time, and we're subtracting it. So 2 minus 1 is 1. So that means that this part of the for loop, for the first row, will only run for one time, and we'll only print one space. So that's why this works. If you're confused, you can test in some numbers for I and see that the number of times that this loop will run will correspond to the number of spaces. So then you're going to say system.out.print. Make sure you're saying print and not print ln here, because you want to print them on the same row. And that'll be the code for spaces. And so for stars, this part is a little bit tricky. So what I wanted to do here is initially logic it with like a formula or something, but I realized that that was kind of a pain. So what we're going to do is, we already know that in a pattern, the amount of like spaces, I'll make spaces as these underscores. The number of spaces you have is the difference in the number of total stars that you're given. So n is the total stars in the beginning. It's n minus the number of spaces minus these two spaces give you the stars. So you can count how many spaces you print and then do some subtraction, and you'll find out how many stars you need to print out. So I'll just say int count is equal to 0. And then over here you'll say count plus plus. So this count is going to get how many spaces you're printing. And then over here, to print your star code, you'll say, okay, we'll say int j is equal to n, so your total number of stars in the beginning, minus count times 2. And the reason I do times 2 is because we have spaces. We're actually printing these number of spaces, but in total we have 2 times that, because we're only printing these, but from the row we subtract twice that amount to get the number of stars. And then we'll do, after that, we'll do this one. As long as j is greater than 0, we want this code to run. And we will then do j minus minus, and then you'll just have to say system. Running out of time here. System.out.print star, and then you'll do system.out.println, and then that should be cool. And let's just run this one time if we can have enough time to do this. Come on, run faster. 9, let's do 9. Oh, looks awesome.